In this section, we will discuss about the H index. In this section, we will discuss about the H index. If I look at the H index basic definition, that means let's say an author has H index of n if they have n papers, each with at least n citations. Each with at least n citations. So here, let's say there are n papers with at least n or more number of citations. N or more number of citations. So this is n is equals to h. So that is your H index. This count is your H index. The formula what it employs in computing H index is H is equals to max n Cn greater than or equals to n, where Cn represents the number of citations for nth paper. Cn represents number of citations for n papers. So let's take one example and understand. Let's take one example and understand how H index works. How H index works. So let's say step-by-step calculation. Let's see step-by-step calculation. So compile a list of all publications. Compile a list of all publications with their citation counts. So let's say this is my first journal paper, has around 23 citations. This is my second journal paper, has around, let's say, 22 citations. Then so on. That's my 13th journal paper, which has, let's say, 1 or 2 citations, and a recent paper which got published yet to be cited, right? And then all the papers are listed, and then we have to sort them in the descending order. We have to sort them in the descending order. And then what we have to do is we have to find out H, where H paper have at least H citations for each, where H paper have at least 8 citations for each. Such as, let's say, I will set up, let's say, H equals to 1. So at least one paper have more than 1 citation. So yes, this is having 25 citations. So it is an in. Then second paper, let's say H equals to 2. Then I have to see at least 2 papers should have more than 2 citations. Yes, both of them are having more than 2 citations. Then so on, I can go and say set H. This is an iterative iterative calculation. So here now I will set H equals to 5, which means how many papers have at least more than 5 citations. So you can see this has more than 5 citations. This, all of them are having more than 5 citations. So all of them will be in. Now I'll move and increase H equals to 6. So now this H equals to 6, we can see how many papers have them more than 6 citations. This is exactly having the 6 citations. So here you can see total number of papers which have 6 citations are 1, 2, 3, 4, 5, 6. So if I look at the basic definition of H index, is that H index of n when they have n papers with n number of citations, right? So if I see here, so or in terms of H also you can discuss that. Finding the largest value of H, where H paper have at least H or higher citations. So here you can see H index is 6. Now if I put H equals to 7, that means the number of paper H paper should have. So 7 papers should have at least 7 or more citations. But here you can see there are only 6 papers which have more than 6 citations, right? So 7 citations is, there are no 7 papers which have more than 7 citations. So this H equals to 7 will not work. We have to stop and say H equals to 6. That means here for this particular example, H index is 6. H index is 6. Okay. So here the value of H reflects the largest number of papers that have been cited H or more times. The value of H indicates or reflects the largest number of papers which have been cited for H or more number of times. So here in this example, H was 6. H was 6. If I look at this example through the Google Scholar, I can see there are 11 papers which have more than 11 citations. 11 or equals to 11 or more than 11 citations, right? 11 papers which have 11 or more than 11 citations. So both of them are counted here, and total count is 11. So that's why a researcher's H index is 11 here. Now there are advantages of H index, such as, let's say, it balances the productivity and citation impact. It balances the productivity and citation impact, and it more resistance to the outliers than raw citation counts. And also it includes the highly cited papers in the count, of the H index. That's why it is overcoming the problem of I-10 index. Also there are some of the use cases, such as, let's say, evaluating a particular faculty or a researcher or a postdoc to clear, to clear his tenure. Mostly the faculties are subjected to tenure. So let's say evaluating a faculty for his tenure track clearance, or promoting from one grade to the next grade or one position to the next position. It is often used to compare researchers within a same field. The impact of researchers' output within a same field. It is often used to do that one also. However, there are few limitations also. And the disadvantages are such as, let's say, it favors the established researchers with long publication histories. Let's say an older researcher has many papers with higher H index, then naturally their count is larger than the new researchers who are just stepping in the field. And it ignores a smaller number of highly influential papers also. It ignores the smaller number of highly influential papers also. There could be a risk of field variations. Different citation practices can lead to disparities between different disciplines. Different disciplines will have different citation practices, and according to that, that may create some sort of issues also. Higher H index is typically in the life sciences compared to humanities. If you look at these two fields, such as, let's say, life sciences, they have higher citation counts compared to humanities. In engineering fields, or if you look at the chemical field or chemistry field, they have little bit of larger citation count than the engineering field. So that's how this H index will go. So we cannot measure the apples to apple comparison between two researchers from different disciplines. However, it is extremely useful to measure the impact of the researchers within a particular same field. It is really useful to measure the impact of the researchers' work within a particular same field.